Welcome students. Today we are going to discuss about the hybrid pi models for BJT as well as the MOSFET. In general, the unit 1 and unit 2 in electronic circuits, we are discussing about the hybrid pi model. In general, there are four types of models out there. One is a basic RE model, and then second one is the hybrid model. Third one is the hybrid pi model, and fourth one is the expanded hybrid pi model. It is the advanced version, and today we are going to discuss about the fourth one, hybrid expanded hybrid pi model. So in general, we are taken the BJT transistor, and it is a common emitter always. And for generally, we have drawn the hybrid pi model. Already we discussed in the previous videos about your hybrid pi model. So base and this end will be the collector. Emitter is to be the grounded. Because it is a common emitter is grounded. So from base to emitter, you have to connect the resistors R pi, and the voltage flowing is V pi, and the current flowing is the GM into V pi and R naught resistor. This is a normal hybrid pi model. While the same diagram has to be expanded by introducing the capacitors in each terminals. So from base to emitter, I am introducing the resistor and capacitors. So it is called R pi and C pi. Same way, base to collector, I am introducing the RC combination, R mu and C mu. The same way, collector to emitter, another R pi RC combinations have to be introduced. So that's therefore your hybrid pi model get expanded. Hence, it is called the expanded hybrid pi model diagram. And when we neglecting this parasitic resistance, because these values are very small, r mu and rc are not, these are not very small. So no r not, okay, r mu and rc, and it will be very much small values and it has to be neglected. We call that one as a parasitic resistance. After neglecting your hybrid pi model, sorry, expanded hybrid pi model diagram will become like this. So it is similar, 99% it is similar as like your hybrid pi model. Only you are introducing the two capacitance. One will be the C pi and another name is called C mu. In later, it will be the C mu, we call it as a Miller effect, and Cm, we call it as a Miller capacitance. So these are the hybrid pi, expanded hybrid pi model of BJT. Then we discuss about the expanded hybrid pi model of MOSFET. The same way I am taking the NMOS. NMOS in the sense arrow mark is to be coming outside from the source, and it is a normal hybrid pi model, gate terminal, drain terminal and source terminal. It is a NMOS, so gate carries positive symbol and source carries a negative symbol. Voltage drop is VGS. And the diamond shape we call it as a GM-VGS, the current dependent. Okay, it is a voltage controlled current source, and R naught is having a high output resistance. It is called as a R naught, and potential drop of output we can take it at this end. And this diagram is converted into expanded hybrid pi model by two layers. So this is your internal layers, and this is as usual your VGS layer, plus minus VGS. So this voltage drop is called as a VGS dash, and this voltage drop is called VGS. Then two capacitors has to be introduced, CGS and CGD, which is working as similar as in BJT, C pi and C mu. The same way it is working as CGS and CGD. Then after neglecting the internal voltages VGS dash, your diagram is similar as like 99% same as hybrid pi model, and only you are expanding the circuit by introducing the capacitors. One capacitor has to be introduced between your gate and source, and another capacitors is introduced between gate and drain, CGS and CGD. In later we call it as CGD is called as a Miller effect, and CM is called as a Miller capacitance, both having the same relationship. So this is your expanded hybrid pi model of MOSFETs. Thank you, students.